Hi, welcome to our company interview. You have the following problem to solve. The problem is that you have to design an experiment case and for a new feature for search page. The situation is the recommender system is not very diverse, and the e-commerce company thinks about a new feature to help users search more efficiently and diversely. So question number one is define a metric to measure whether the change is good to the business or not. Question number two is how do you test this new feature? Hi, that's a good question. First, I will define a few metrics to be considered. A. Sensitivity. Sensitivity is a good metric and that should be correlated with the user interaction, i.e., users need to use this feature. Metric number Metric B. Robustness. Robustness is relevant to business goals, and it is important to business growth or profits. Metric C, not affected by other features, things you can't control. You should not contaminate your metric measurements. Imagine or think about the funnel analysis. Visualize how a user interacts with the product or the website and other possible metrics like click-through rate, click-through probability, conversion rate, etc. Click-through rate or CTP is more robust than than click-through probability is more robust than click-through rates because click-through rates can be easily contaminated by other existing features. In this case, statistical analysis may not be reliable. Now, after explaining the metrics and also metrics that I mentioned before, which are sensitivity, robustness, and also is independence of other features, I will set up the experiment right now. So the experiment is I will translate the problem into statistical testing, which means the A/B testing, which I will explain later. Experiment two is I will define my null hypothesis, select the test statistics and the underlying assumptions. So what uh, what uh, what do they mean? They mean three different things. First, I will test two click-through probabilities under null and under new feature. The other thing is the other thing is I will make sure that the sample size is large enough for me to apply the click through the CLT, um, which I forgot what that it means. The number three is I will use the C score to test the statistics. All right, now according to the business goals, I will set up the confidence significance level, effect size, and statistical power. To read it again, I will set up the stat significance level, effect size, and statistical power. What do they mean? They mean I will compare the type 1 error versus the type 2 error. I will compare the false positive rate and the false negative rate. And I will compare the power analysis and trade off. And then I will ask the interviewer which factor is more important to business. Okay. Now, I will calculate the required minimum sample size and experiment duration. I will calculate the required minimum sample size and experiment duration. Mhm. So, what is the baseline conversion rate? What is the expected effect size? And how to sample users, how to use randomization according to traffic, how to use randomization according to blocks, and other separable features like regions, locations, devices, depending on the features. And what if you can't do pure randomization, cluster randomization, and so on and so forth? And how long the experiment should run? For example, they should run for generally 2 to 4 weeks. And what if I find a statistically significant result with minimum sample size? Should I stop the experiment? The answer is no. You need to consider the user time to adopt or user novelty effect, meaning that early observations may not be representative. Start counting observations when sample size is relatively stable. Also think about holidays, seasons, weekends, big events. Try to cover try to cover broadly enough, not too short, not too long. Since there is a trade-off, longer time means that you may lose opportunity to launch new experiments. So yeah, so that's what I said. Third, you have to collect the results and make a decision about to launch it or not, right? You first collect the results and now you make a decision about to launch or not. How to make that decision? You have to make the decision based on the back of the envelope calculation or cost analysis. If you launch your experiment, what is the loss if due to false positive? What is the loss if what is the loss that is due to the false positive rate? What is the expected cost for launch? If not launching the experiment, what is the expected gain from the significant results? Also, there are opportunity costs, trade-off for other experiments, etc. Fourth, back to the selected metrics and the business questions. Always tie your analysis to the business questions and business goals. And also think about other metrics, how to improve, what not to be considered, etc. So I talk about how to use this recommended random system and how to calculate the minimum sample size and conversion rate and set up the experiments and uh, I have explained it pretty thoroughly. So the above is my are my answers. Thank you for answering this question. The answer your answer is very great and very thorough. I enjoy listening to your answer. So my next question is, can you explain what is overfitting and how do you detect overfitting? Overfitting is about a bias and variance trade-off. If the bias is high, I will have underfitting, which means I will have a simpler model and hypothesis class. If the variance is high, on the other hand, I will have overfitting, which means I will have a more compressed model or hypothesis class. Overfitting models generally have larger prediction errors than training errors. When doing model selections or feature selections, we face a bias variance trade off, and we can apply cross validation to track and compare training versus testing errors as a guidance for model selection. I will give an example to explain what overfitting is. For example, linear regressions versus polynomial of p order. Higher order polynomials tend to overfit the new dataset. Thank you for that answer. So my next question is, can you explain what is k-fold cross-validation? How to determine the value of k? K-fold cross-validation is a method used to do model selections. Say we have multiple models and we want to know which one is better performed. One way to do is to split the whole dataset to training, validation, and testing sets. Here, K means how much subsets we want to split between training and validation sets. After splitting into K-fold subsets, we train each of our candidate models on the K-1 subset and validate on the Kth subset. We then calculate the average errors for each candidate model and select the one with the lowest average errors. Regarding the value of k, if we have a large sample size, a common split is 80% versus 20% training versus training testing sets. However, if we have a smaller sample size, we may want to use leave one out cross-validation, which allows us to have more training data than testing data. In other words, we try to overfit the model given smaller sample size. Again, bias variance trade-off applies here. Thank you for the answer. My next question is, for a binary outcome with many features, how do you assess the performance of many different classifiers? I will assess the performance of different classifiers based on five different metrics. The first one is precision, which is equal to the accuracy of positive predictions. Now, mathematically, it is the true positive divided by true positive plus false positive. The next metric is recall. Recall means the sensitivity, also, which mathematically is equal to 1 minus type 2 error, or 1 minus beta, and it is equal to the true positive versus true positive plus false negative. Next, I will have the false positive rate, which is equal to 1 minus specificity, which is the type 1 error. And next, I will have the false discovery rate, which is equal to the 1 minus precision. And at last, I will have the F1 score, which is the harmony average of precision and recall, more preferred to use in unbalanced classification models. Thank you for your answer. My next question is how to choose different classifiers before choosing the threshold of probability y equal to 1. That's a great question. Your question is how to choose different classifiers before choosing the threshold of probability y equal to 1. I will use a method called area under ROC. ROC means ROC ROC means receiver operating characteristic, which I don't know what that is, to be honest. And I will plot the recall versus false positive rate. The larger the AUC, which means the AUC means the area under ROC, the better the model to choose. Or I will choose the model that have lower AIC or BIC values. Thank you. That is a very specific answer that I'm looking for. My next question is, given the above two classifiers, which model will you choose if you require a sensitivity of at least 0.7 and if you need the specificity to be at least 0.9? Now you set sensitivity to be at least zero point 0.7. Sensitivity means power, and power greater than zero point 0.7 means we would want to choose the BRAC ROC model. And if you want the specificity to be zero point 0.9, again, specificity means the significance level. And if you want it to be above zero point 0.9, we want to choose the red ROC model. My next question is, you are a doctor who has built classifier for cancer based on the results of blood tests. What would you choose, RAC or BRAC model? And what would you set the thresholds to in each of the following scenarios? Scenario number one, you will administer chemotherapy to the patients classified as having cancer. Scenario number two, you schedule more tests, more expensive than the first test, but less than chemotherapy, to better evaluate whether a patient has cancer. Mhm. Thank you for the question. So your question is if I would choose the red or black model, and how do I set the threshold for each of these scenarios? And you have asked me we about two scenarios. And scenario number one is that I will administer chemotherapy to the patients classified as having cancer, and the second scenario you have given me is I will schedule more tests, more expensive than the first test, but less than chemotherapy, to better evaluate whether a patient has cancer. So I will I will first of all separate into three different situations. Situation number one: if we just do one test, we want to minimize the false positive rate or having a higher significance level. Thus, we want to choose the red ROC model. Situation number two: if we do multiple tests, in the first test we want to control sensitivity, give a higher power of it, which gives us lower false negative. Lower false negative means I will have a lower type 2 error. In the second test, we then want to control the false positive rate, lower type 1 error, for those classified as positive from the first test. Therefore, for multiple tests, we choose the black ROC model in the first test, then red ROC model in the second test. Thank you. My next question is, with plenty of features available, how should we select the most important features? That's a good question. I will give a very broad answer for it. First, we need to ask how big the sample size is. Why the model with features uh, why the model with features is not preferred, and what algorithms and model will be used. What is the goal of modeling? Understands the context before answering. So if we have a small sample size and we want p way larger than n, we can't do a classic regression model because xtx is not full rank, not invertible, meaning that we can't solve model coefficients. There are a few methods to do feature selections. For example, forward selection, iteratively adding new feature that significantly improve model fit. Backward elimination, iteratively dropping existing feature that insignificantly decrease model fit. Here, model fit metrics can be AIC, BIC, etc. If we have large sample size, but we want to reduce overfitting, we can consider regularization methods such as LASSO, which will force coefficients to be zero for those insignificant features. We can also use PCA to reduce feature dimensionality. Another thing is to consider another thing to consider is multi-collinearity. Do some features have high covariance? With the presence of multi-collinearity, estimates standard error of coefficient will be larger, leading to higher false negative error, or higher type 2 error, or equivalently lower power. Do we care about feature interpretability or point estimate and confidence interval? If we do, or if we do not, if we just care about prediction, multi-collinearity is fine to be ignored since point estimates are not affected. But the confidence interval of point estimates will be wider, and thus interpretation of coefficients may be invalid. We can use rich regression to shrink the variance of estimate coefficients at the trade-off of introducing some biases. Rich or L8 SSO regression increase the power of estimates. We can also use random forest algorithms, which are more robust to multi-collinearity. Thank you. Can you explain what is decision tree, random forest, backgain, and boosting algorithms? Decision tree keeps splitting nodes based on the feature cutoff threshold. Backgain or bootstrap aggregation, random sampling replacement, train on these samples using decision trees and aggregate to get an average classifier. Random forest or random sampling on a subset of features with replacement, shrink and aggregate to get an average classifier. Random forest introduces more biases but gives less variance. Boosting, random sampling but with more weights on misclassified observations. Train and get an weighted average classifier. Boosting introduces more variance but gives less biases. Thank you for the answer. Now I will move on to the final interview question. So this is a case study. You now in this new product case study about a new search ranking algorithm. Imagine that you are in an e-commerce company and we design a new ranking algorithm for search query. How do you measure whether this new ranking algorithm works or not? What metrics can be used to assess its performance? What other features or factors do you think may affect its performance? How do you know? List these factors in buckets and present them in decreasing order of importance. Thank you. I will think about more metrics, not just those often used ones such as click-through probability or conversion rate. They are the standard answer. However, although I think about something called a quality score to measure the performance of ranking algorithm, I probably do not want to elaborate it in a good formula. My thought is to weight average the click-through probabilities over top k slots, which each slot weights being decreasing with respect to their corresponding positions. Then we calculate and compare the quality score for both old and new ranking algorithms. We would prefer new ranking algorithm if the calculated quality score is significantly better than that of the old algorithm. So the quality score is my answer, and my idea is somewhat similar to something called the DCG metric, though I didn't know any of them before searching online. Of course, there are more metrics to evaluate the search ranking algorithm. For example, the discounted cumulative gain (DCG) which I just mentioned. It is a canonical metric that captures the intuition that the higher the results in the SCR pre search engine results page, the more significant or more important it is to get it right. The other is the normalized discounted cumulative gain, or NDCG. Others are precision, recall, mean average precision, mean reciprocal precision. Thank you for the answer to my final question, but I do have a follow-up questions to you, which is a surprise. So, what if the overall performance of new ranking algorithm is better than the old one, but the first lot click-through rate is lower than the new one, lower than the sorry, no lower than the old one? Do you decide to launch the new algorithm or not? Um, yeah, I don't know the answer to that. I think the interview takes too long, and I probably have to leave right now. So I will leave the questions to the audience to answer. Thank you very much. Bye bye.